Okay, so how should we analyze decisions like this? David, do you face some uncertainty in admissions?
All the time.
What kind of uncertainty do you face there? I mean, I know there's lots of different types, but
I'd say the biggest one is obviously whether or not students.
right, we were just talking about it before we started tonight. So, you know, what's the chance that somebody who paid a deposit, said they were coming to Ottawa, is all of a sudden not going to show up on move-in day, and they just vanish? About 5 guys, just no shows. Yeah. So, you know, how do we account for that? So what do you think? Let's kind of stick more to this example. I just wanted to throw that out, that we have some ways to deal with uncertainty like that. It's kind of quantitative in nature, but
I mean, could they just deal directly with that client themselves and still use, you know, distributors for other clients? Like if this is their largest client, can they just do that separately on their own?
they can, but the thing they don't know is whether other ones are going to be ticked off about that and alter their current business model.
Okay.
So if they say, well, hey, if you're dealing with them, why don't you deal with us direct? You know, and so then if that happens, it's going to kind of fundamentally change their business model. All of a sudden, they're getting into a business that maybe they didn't want to, because it takes different skill set, right, to be on the retail side versus the wholesale side. So I just, one thing that came to mind was the nursery, the Loma Vista, is that the name of it? Southern Ottawa, right off the freeway. You guys have seen the just acres of plants and trees and shrubs and whatever. Well, they are exclusive wholesaler to places. They don't do any retail business, right? But you look at it, and they've got nice plants there. I mean, you drive by, and you're like, oh, let's go stop there. They got lots of variety or whatever. So they could sell directly to the consumer. But in order to do that, they need to have a person up front at a cash register, and people checking, and maybe security is different, and, you know, all kinds of stuff. Safety measures that, you know, if there's a slip and fall compared to running their nursery, you know, the way they have it there. So there's all kinds of issues that businesses might choose to stay on the wholesale side. Yes, they're not getting maybe as much money as they could on the retail side, but the economist would say, well, there's a value add. The people who are serving retail, they've already got economies of scale and other things with the customer service and the store design and the safety measures and, you know, all that stuff that we don't do on the wholesale side, they've already got taken care of, right? So, so that's not a trivial thing to break that. So the fear that the retailers would have is to say, well, hey, if you're going to start taking my customers away, because they're going to go direct to you, right? And so then they're like, well, screw you, we'll go find another wholesaler or whatever. And then that might rock the boat on the rest of the business. So their largest clients want to deal directly with them, avoid the middleman. They might lose large customers if they don't switch. So they're kind of a large chunk. But they might lose distributors. That's their other, you know, people if they did. So right now, the large customers have to work through those distributors, right? And so now we're trying to jump that middleman is the issue here. So how should we analyze decisions like this? What would be the, you know, if this was your problem, we're missing a lot of details, so you can make up stuff as you go here on your, just your thought process on, you know, what would be some of the things if we're in the boardroom now and you are the MBA student that just got hired and the boss says, here's the deal, what do you think? How do we approach this? What are some ideas?
Well, you have to weigh each decision, which one, you know, how much you're going to make if you do this, and, you know.
Okay, Peyton, you want to add on to that?
Yeah, I was just going to chime in. So, obviously we don't have all the numbers and breakdown, but like opportunity cost, which we're gonna make, or, you know, how much of a loss we're gonna take.
Okay.
The margin larger or large enough to cover the loss that you would consume if you switch.
Okay. So yeah, you're starting to say, depending on what the numbers are, if one really overwhelms the other, then it might turn out to be a no-brainer even, right? So when we take a problem like this, we can start to think about what is the state of nature or whatever, what state are we in is kind of the words we use in probability and statistics. The state of different outcomes / payoffs. So it's helpful sometimes to use a decision tree similar to what we did with our game setup. Although here we're adding probability into it, and there we were like, I can either decide to go here or here, and maybe it was with 100% certainty what I would get was how this is putting a little bit different twist than what we did on with the game theory, where we saw the payoffs for each party, and then we could rationally go through and calculate, like in the mixed strategy equilibrium of the coin game, the matching pennies, we could statistically calculate that the optimal way to play the game is to flip the coin, or to do something with a random probability of 50%. That's a little different here, where we're talking about probability. It's not in some ways too different, but there we were choosing to play the game. We were letting a randomization technique be how we played the game. Here, we're looking at the probability of different outcomes, not necessarily by our choice, that we can choose it to be 60% or 40%. We're just stuck with it. We think that there's a 60% chance of this happening, 40% chance. And then we need to look at the outcomes or payoffs to make a decision on that. So our decision is dependent upon expected outcomes. Expected outcomes. And again, with the previous chapter, we had more certain outcomes. Not necessarily. There can be a blending, but for most of the games we looked at. So expected outcomes. All right, so we'll see how that kind of plays out here with the math. So here's a couple boring, statistical equation type looking things here. So a binomial random variable is kind of the technical name we give when something has the possibility of being one thing or the other. So the outcome here, x1 or x2, is a random variable, and it's got probabilities of that state of nature coming out of p and 1 minus p. Now what's that all going on there with p versus 1 minus p? It's usually rho actually, but I think we just use p because we didn't have the Greek characters. But I can't remember the textbook actually. It's more like this, a little p, it's a rho, the Greek letter rho. P, 1 minus p. How does that work with what's going on here with a binomial random variable? Why can we write it that way?
P is the probability that you have, and 1 minus p is the probability of value 2 in that example. So 1 being 100% minus the probability that you have.
Good. So the probabilities have to sum to 1, or 100% if we're dealing in percents. So if we know that the chance of x1 occurring is 0.2, if it's a binomial random variable, there's only 2 states of nature. By default, all probabilities must sum to 1, so we know that the probability of x2 is 1 minus 0.2 is 0.8. So that's what's going on there with the 1 minus thing. If you know the probability of one event, you know the probability of the other. Because the sum of the two have to, or the sum of the two probabilities have to equal 1. All right, so we can do this with 3 variables, or we can do it with 4, 5, or 6. So we can have lots of chances of different outcomes happening. If you play a little roulette, do we got any roulette players out there? How many outcomes do we have on the roulette wheel?
Almost half black and half red. It's one.
That's right, and then you got those 2 little greens, right? And which is 0 and double 0. I honestly haven't played roulette. Hopefully I won't kick myself, but I think it's 36. 1 through 36 is black and white, 18 red, 18 black, and then the 2 greens make it 38 outcomes. So 0 and double 0. So there's 38 possible outcomes, which means what's the probability of this? Well, we've got all of these, and since they're equally weighted, in theory, unless the wheel is rigged, then each one has a probability of 1/38 of happening. So what's the chance of it hitting 1? It's 1/38. What's the chance of hitting a double 0? It's 1/38. So there can be multiple. So here we've just got the 2 variables, 3 variables. Notice that we need 2 of the probabilities to then solve for the 3rd one. So same thing, all probabilities must sum up to 1. So the chance of x1 occurring is probability p1, p2, and then 1 minus p1 minus p2 gives us the probability of x3. All of this then gives us the expected value of the random variable x is a weighting of the values of x and the associated probabilities. Okay, questions there? Just to kind of tee you up. All right, so let's go back to this example. If they sell only through dealers, the probability of losing large customers is 0.6. So 60% chance of losing large customers. If they sell directly to large customers, the probability of losing the dealer distributors is 0.2. So we got 0.2 and 0.6. So what's the probability of not losing large customers? Careful, how much? 0.4, right? And the probability of not losing dealer distributors, 0.8. So again, we're going to kind of set up this blending idea. So here's how we can use the decision tree. Here's our firm. Sell directly to large customers, or just do the dealers. So that's kind of our 2 choices. And now we want to calculate, because there's uncertainty, here's the uncertain part. Distributors leave, 0.2. Distributors stay, 0.8. Large customers leave, 0.6. Large customers stay, 0.4. And then the one thing we didn't have before is now the profits of each state of nature. $30 if this outcome happens, 130 if this outcome happens. 100 if this outcome happens, 130 if this outcome happens. Go. Calculate this, calculate this. I'll come around and try to help you. I want to see pen on paper and have you guys try to solve that. I'll give you a hint. It's following, I'll just rewrite what we did in the previous overhead, which was P1 times X1 plus 1 minus P1 times X2. That is what I want to see on your paper using this concept, applying it to this problem. instead of X.
Yes.
But just because when we write this stuff, kind of try to tell a story with the variables when it's possible. It's just kind of nice. Okay, yeah, keep it going. We're trying. Yep, keep going. As soon as you get an answer, let me know.
Expected profit for selling directly to large customers is
Okay.
$100. And the expected profit of selling through dealers, I got $112.
Okay, profit through dealers. And so this is one way to do it when I was telling you to kind of do it a little more specifically, because we're really calculating two, right? It kind of helps your brain when you put it that way. Expected profit through dealers, expected profit through large customers, even if you kind of do it abbreviated like this. And then what also helps you do is if you ever need to do a write-up about it, like literally put it into words as a description to the CEO or something, when you kind of write it out that way, it just kind of talks to you right off the bat as you look at the equation. All right, so give me your numbers again. Large customer was what?
110.
110, okay. And what was your
Directly to the
dealer?
112.
112. Okay, you got the same, Donald? Peyton, how are you doing? Let me see your work. As long as you show your work, that's always the advantage of that. Then it's just a calculator error for times three.
Like, man, do I need
Okay, now get rid of that X2
P2
because
somewhere?
you're
That's
doing
what
100, you got an 80% chance of getting 130,
Okay.
right? I'm going to show you the equation, but you're close. So again, knowing these pieces to the puzzle is important as you set it up in your brain. It's always, you know, if you don't understand, the math is one thing, but if you don't really get kind of the basic principles here, and the basic principles are really this. At the end of the day. But I've only got a 20% chance of getting this one, and an 80% chance of getting this one, and so by blending them together, that gives me a total expected profit of selling directly to large customers of 110. That's fine if right. If it's this type of equation where you've got it, yes. And really showing your work here, even showing just like this, is fine. Yeah, just 0.2 and 0.8, and yeah. I mean, it depends on what the question's asking, but yeah, this is all I was looking for, is to really get this, because this is doing something weird. This is not what normal people do. This is what MBA econ students do when you look at expected values. You just don't usually treat it this way, right? You do maybe in a sense sometimes qualify it that way in kind of a hunch type way, right? Where you're like, you know, the CEO doesn't even calculate this. They just say, oh man, we got a 20% chance of getting 30, an 80% chance of getting 130. That's pretty good odds. I think I'll just go with that. Whereas to actually do the math with it is kind of this next level up. And especially when things get a little tight here, we got 110 versus 112. So what should we do? What should we do? Sell only through dealers or sell directly to large customers? Still do large customers? That's Donald's vote. Everybody agree with that?
My mind tells me to go with a larger expected value, which would be through the dealers, but rationally I'm thinking 80% of getting $130 is a really good odds. I would probably, that's just me thinking aloud though.
Okay.
So I don't know what the correct answer would be, but that's my logical thinking. Yeah.
Yeah.
If you
So what are some things that you guys that your gut is leading you to the wrong answer? Because the correct answer, numbers-wise, this is saying what you were going with. The 112 is greater than 110. I like more money as opposed to less money, so I go with this. But I want you to look a level deeper at these to say, why is your gut, you already told me the first half of why you think this one feels a little bit better. I wanted you to get over that. I want to, what are you missing over here that makes this a better answer, perhaps? That you kind of overlooked, almost a human bias, perhaps.
I look at it, both values are greater than or equal to the other side.
Uh-huh.
I mean, $30 looks nothing compared to $100. I thought that too.
Yeah.
But I'm just looking at the total greatest single value,
Right.
which is what I was doing.
Right. So you see how you're kind of overlooking this
Yes.
part, where after you sit there and try to digest it, that's why the numbers can help you see things that your gut maybe didn't let you see, because you were clouded a little bit by some of these human biases, perhaps. Of, 80% chance of getting this, let's go for that one. But here, you've got a 60% chance of still getting 100, which is actually pretty good. It's not too far off. That's what you're saying. After you kind of look at that, you're like, oh, okay, well, 100 and 130, the spread between the two is actually less risky in a sense that way,
Yes.
right?
Yes.
So as we sit there and try to kind of really dive down deep, what hopefully the takeaway from this is that this is a valuable exercise to at least calculate the number. And now, what would cause you to maybe say, I know the numbers came out to be 112 and 110, but what would make you for sure want to go this direction? What would you have to know about the problem that would make you feel more comfortable with that going this way? Because let's face it, 110, 112, it's $2, right? It's kind of close. But what do you need to be pretty confident of in order for you to maybe say, you know what, 112, the numbers tell us that. Even though my gut's telling me here, let's go with the numbers. That's what I learned in my MBA class. Just go with the numbers.
Yeah.
Okay.
My concern is probability. How are we certain that probability is going to stay the way
Good. That's exactly what you need to be looking at. Like, is that probability tight? Where did that come from?
Yeah.
Just 60% like, I think it's probably a 60% chance. Well, what if it's 58% chance, right? How does that change it? In other words, we can start to do even a little bit of a sensitivity analysis. In fact, I think it'd be useful to do that. Let's go ahead and change this. I have not cooked these numbers, so I don't know where this is going to go. But just for fun, let's do 65% here and 35% here. I'm sure that's going to tip the boat over, and there's ways we could kind of solve for the equilibrium, but yeah, so 65, 35. That should lower the 112 to, I know this answer is 65. 65 plus 35% of,
and 110.50.
no way, really? 110.5? Okay, I was just pulling that number out, but that's my point, right? Is that if these probabilities are kind of fuzzy, then you might start to go towards other decision criteria, possibly of, well, this one actually has greater variability. So if you're trying to, we even talked about this last week, avoid the worst outcome, this is the one you'd want to avoid, right? Because you don't want the 30. 30 sucks. So other strategies might play into this. So I introduced this type of material with a caveat of it's not a single solution for you to all of a sudden have the decision. It's just another tool in your box. And so what it did for us is it helped us see some things that maybe our gut wasn't able to digest right away without carefully looking at it. So it's just another tool in our box. Okay, so that would this one would be tilting under those numbers anyway, quantitatively with going through with the dealers. Okay, so So it's real common to not know the demand. And I like to bring up these human bias things because it's kind of a fun area of economics. And if you're a new business and you're opening up a new restaurant, you're doing something new or whatever, what do you think how would you tend to be biased? Would you tend to think that there's high value customers out there or low value customers? If you're starting up a new business. You're starting up a new business and you're trying to say, wonder if anybody's going to come to my restaurant or not, and I think, they're good. How do you think you would tend to be biased, thinking that things are more favorable or less favorable?
I mean, I can see both sides. If you're starting a new business, you've obviously gone in with the intentions of knowing you're going to make something. So you're going to go on the bias knowing you're going to get more. But me, I'm innately negative. I'm always worried about the bad and how it's going to get worse.
And that's why I tried to kind of phrase it as, if you're most entrepreneurs that you guys know, which do you think they're going to do? Are they going to look at the thing more favorably or less favorably? Probably more favorably, yeah. Entrepreneurs are just that way. It's just like, yeah, rose-colored glasses. The glass is always half full, not half empty, blah, blah, blah. Then they need the Davids of the world to work for them and say, listen, there's a chance that if it's 5, this is how it's going to work. This is so a good entrepreneur will have a team around him or her that can bring in some of those angles. Because a lot of times, those new startup businesses tend to have those rose-colored glasses on. Okay, so back to this. So to model this uncertainty, classify the numbers and type of potential customers. For example, we got people out there that we think would pay $8, people out there that we think would pay $5. Suppose there are equal numbers of consumers in each group. So the question here, we're taking as given that there's people out there that are willing to pay. We just don't necessarily know. And we're going to assume that there's equal numbers in each group. So how should we price our goods? Should we price it high or low is kind of the direction we're heading with this problem. Price low. Why?
Because if you price at 5, you're going to get 20 customers, which is $100. But if you price it at 8, you're only going to get 10. I'm just assuming that's 10 for each.
Okay.
So if you price it at,
So go for volume.
yeah, price it at maybe more, price it at 5, you get 20.
So one thing you're bringing up is if you price it low, you're going to get all the customers.
Right.
Right?
But if you price it high, you're not going to get half of them, and it'll be more. You make more if you price it low, you got more customers.
Okay.
The spread here is
And
not
then
large
just in this
enough to do a
example.
problem.
Okay.
I agree
Peyton?
with that. And to his point, if you had 20 people, you're going to get $100 in comparison to $8.
Right, that's what I'm saying. Or you get the 80.
Okay.
Yeah.
All right.
I feel like I'm wrong.
So one thing that you didn't bring into account, because you're only on the revenue side there, right?
Well, that's all we had.
I know. No, I didn't mean to trick you, but I'm saying those are some of the things that we need to think about. Like when we had the revenue model of demand, unitary elastic, halfway, eyeball it, this thing with total revenue, quantity, price. Demand's up here, lower price, what happens to revenue, right? Depending on whether it's elastic or inelastic, we learned there that, that was one thing. I only bring that up to the point of we're not out to maximize revenue, we're out to maximize profit. So, with marginal cost equal to 3, now we got a little more meat on the bones too. But your thought process was good on kind of the type of issues. Now 8, why?
Because he's saying, 10 people eat, you charge 5, you're going to make it $2 per person, or $1. So you're still getting 20 customers, but you're only making $40.
Okay.
Whereas if you do $8, $5 per person, you make 50.
Good. Right. So you're getting half the market, but you're actually making more, right? So it's kind of this interplay of cost and revenue that's important.
I had already calculated everything. I'm ready to go.
All right, good. So you guys kind of nailed all these points here. So 50% of the time if you price high, 100% of the time if you price low. And then here's our little chart. If we think about the high price, we lose half the market. So this is kind of, to me, a little bit counterintuitive way to even present it. But you've got the $5 worth of profit, getting half of that, and then you get nothing from the low value customers, because they're not going to buy it, right? Whereas we capture the whole market over here, and so on average it's 2 or 250. And so whether we got 20 customers, I like that you did an example in your head. That's a great way to. The answer's all the same under these circumstances. So good. Okay, questions? Further discussion there? All right, so a little price discrimination. When buying a new car, salespeople discriminate between high and low value customers. How do they do that? Do they have a sign posted that says, all women pay this price, all men pay this price? No, that'll get them in jail. Okay, so we know that it's not that type of discrimination. It's the legal kind that we reviewed in the previous chapter. So what are some things that they do?
Income, or maybe a certain income you have, you want to see more high value.
How do they get income information? Do you fill out a FAFSA form when you buy a car, or? Okay. Okay, so yeah, once we get to a credit application, they might know some of that income stuff. Okay, now that's fine. Good things to point out. What about before we actually fill out a credit application? What are some other things? Physical appearance, good.
Perception and behavior.
What's that?
Perception and behavior.
Like, what are you thinking?
Someone walks in there with Carfax listed Ford and a bunch of other car retailer compares prices.
Uh-huh.
You know that they're shopping for the lowest value. They care about price.
Okay, good, good. Yep. All right, so we got things that you can do. I think maybe we talked before. I think that was before on the whole who might like to negotiate, who doesn't. If you're a high value customer, then you just kind of want to get the deal done and not mess with negotiations and their tactics of, well, I have to go talk to my manager. I can't make pricing decisions, and so then kind of a good cop, bad cop type of setup, and all kinds of things that might let high value customers just pay the higher value, and low value customers are willing to hassle that and incur the hassle fee, if you will. Okay, so with price discrimination, remember identifying the two groups in a legal way and then charge different prices to each one. So in an ideal world, in this particular example, we would try to discriminate and charge the high price to the high value and the low price to the low, and then now we're going to get the best of both worlds. So from that example, we didn't get any of those people at the zero. So this one's kind of easy to pick on. In fact, let me just go backwards to it. This one's kind of easy to pick on. If we're able to price discriminate and do it successfully, and we talked about the 3 different things that you need to be a successful price discriminator: separate out the markets, no resale between them, that kind of stuff. So we're going to get the 250, but then we're also going to get $2 on the low value. So this equation will change dramatically. It'll be the 250 plus the other people that we can pick up and make money off of them on the low value side, as long as we can separate them. And then we'll start to see the revenues climb. In your example, we'll have, you had a total of 20? So 10 of the high value, and then it's just kind of all gravy on the other people, whatever we can pick up in profit. Even if we priced it, by the way, at $4, but obviously we wouldn't do that if we knew that they were willing to pay $5. Okay. So, what can you do to defeat the price discrimination scheme if you're a customer and you're engaged in, now would this be direct or indirect price discrimination? Direct. Which was the difference between direct and indirect?
Indirect means no way of monitoring.
Okay, there's no way to legally separate them out, right?
Like college students, for example.
So, if you're to defeat a direct price discrimination scheme that has a college student discount, I could modify my faculty ID, which of course I've done, to show that I'm a student at Ottawa rather than faculty, because they look awfully similar. If I pull it out here, I don't think I can't remember if they've changed them. Where is that sucker? I haven't looked at it for a while. I haven't had to pull it out. Oops, that's my gift card to the bookstore for doing something. I can't remember what. Yeah. So isn't yours basically just like this? And this is an older one, but minus the employee. Or if I modified it and put student over here, I could get real crafty, right? And, or as I'm going up to buy something, I just say, oh, a student discount, right? And I'm Ottawa University, kind of put my thumb right over the old employee part, you know, whatever. We can do kind of some fun stuff like that. And then all of that's going to do is defeat that. And so, of course, the seller can have a mechanism, if they train their employees well enough, you know, take the card from their hand, you know, look at the backside, look at it, inspect it, look for the employee, look for anything, you know. If it's a freaking small French fry that you're getting 10% off, is the employer going to be all like that? No. If it's a car that you're getting 10% off of compared to a bag of small fries, yeah, then all of a sudden, let me see that ID. Is that thing real? You know, let me do a little scratch test on it or whatever. So that's just a judgment call on the business to try to overcome that. Now, with an indirect price discrimination scheme, we can look a little different when we come in. So I'm a high-value customer, but I'm going to carry that Carfax report in, or I'm going to dress down that day and wear kind of some crappy clothes, even though I'm used to wearing all fancy, highfalutin clothes. And if I'm a woman, maybe instead of being draped in ice and gold and, you know, all rock, I'll kind of put those away that day, right? So that we can try to come up with ways to play the part. So one thing that I do myself personally, I'll just tell you one of my insights. I have a 1997 Ford Aerostar that is probably, in my opinion, the ugliest vehicle in Franklin County, bar none. It's rusted out along the bottom. Basically, my parents gave it to me after they were done with it, and we could use a vehicle for hauling materials and whatever. So when I go garage sailing, or if I need to go buy something and have some bargaining power, I take the old Aerostar. I don't take the Jaguar. You know, you kind of lose a little bargaining power when you pull up to the garage sale in the Jag as opposed to the Aerostar with my dogs hanging out of it, right? So we can kind of change that, change those perceptions or alter those if we're clever about it. All right, so give this a read. This is a topic on a different way to think about things, what you're giving up. So I'm not sure there's any end to this debate here. You know, you talk to some people and they take it as gospel. Well, the scientists said that, you know, there's global warming, and then if you start to investigate it, there's other very credible scientists on the other side that would say there's a lot of evidence that says the polar ice caps aren't melting, that there was actually an increase in ice, and whatever. So I've been around and looked at some of this long enough to know that there's at least competing evidence on it. And so some of the changes we've seen recently have been more of a political football on if the public has started to believe a certain way, and you believe that way, maybe that's something that can get passed, regardless of whether there's been a good cost-benefit analysis done at the margin for each type of action. And then what's more interesting is when we start talking about the end of the world because of global warming, or human suffering because it's coming in. I just heard a statistic today, actually, that was kind of shocking. I don't know the full credibility, although they said this was according to scientists who support doing things to, you know, keep global warming from happening. And they said the new rules that just came down the pipeline from the Obama administration for lowering carbon emissions was going to be predicted to lower the global temperature by 1 degree in the year 2200. If we did it now, the result will be lowering the global temperature by 1 degree, according to their predictions. So the question is 1 degree going to save the planet, or is it a start, or does it, yeah, lots of interesting issues, but at what expense is what the economists would ask. So we've lowered the benefit to the world, if you will, is that we've lowered the world temperature by 1 degree. If the scientists are right, we've lowered it 1 degree by 2200. So what are we in here now? 2015 this year, right? So we got 200 years almost. In 200 years, we'll lower it 1 degree. That's the benefit. At what cost? So what does it cost for people to not be emitting? How much of the price of goods and services go up by companies being forced to clean their plant? You know, if it's a car, does that add, and I'm just making up numbers now, but let's say each car costs $1,000 more to manufacture in order to do that, or maybe it's $50 more. But if you take $50 times every car that's produced in the nation, all of a sudden you're starting to run into, you know, what's going on the expense side. All right, so those are some of the interesting issues surrounding global warming, and how do we tackle that now when we're talking about the end of the world and the impacts, things that are far off into the future. And so this error cost is one technique that we can do. So we've got two types of errors. A type 1 error is to do something when there's nothing to do, right? So that's like, oops, I screwed up. I implemented carbon tax in this example, but it turns out global warming is not caused by human activity. At the end of the day, that's what we learn, right? And so it's like, oops, I screwed up. What did that cost me? What was the cost of that screw up? Type 2 errors is the failure to do something when something was actually going on. Right? So I failed to implement a tax when it turned out that it really was caused by human activity. So in each case, we screwed up, or the potential's there for screwing up. And the change in focus with this analysis then is on the errors rather than on the costs and benefits, right? It's like what would happen if that goes on, and so we've got something like this. So with a carbon tax, we've got the probability of these errors, and so the same thing going on, 1 minus p. So if the probability of this going on is 3% and this is 97%, or vice versa, at what point does it make sense to change? All right, so kind of get the difference there on the error cost. It's kind of an interesting twist, different way to do it. Our decision making should be the same. So the optimal decision from an economic standpoint is simply to go with the smaller expected error. So now we're going to minimize error rather than maximize profit, for instance, or expected profits. We took the 112 instead of the 110. Now we're going to minimize our expected error according to the valuation of the cost in each state of the world. So this last comment here is just on pricing. We might see this with businesses as, if I priced too high, what is it going to cost me? What is the cost of that error? If I price too low, what's going to be the result? In some cases, it's the type of information, like where do you have better data? Do you have better data on the error side or on the benefit side where we can calculate it more? So that might help kind of drive this result. And the reason they put in airlines, hotels, cruise ships, those were kind of those big ticket items. We have a capacity issue that we'd like to, if we undershoot it, we've just got wasted space in the hotel room. And so it might be better to model that with this error. All right, comments there? All right, couple terms that often get sloshed around together: risk and uncertainty. Well, there's risk involved with that. Well, there's uncertainty involved with that. And so in layman's terms, we interchange those quite a bit. But we're going to be trying to be a little careful not to do that. So, risk and uncertainty. What do you guys read into these definitions here? What are some, from what we've done tonight so far and what you've learned in the past, what's your take on risk versus uncertainty? Is that making sense? Is it resonating a little bit? Is it a little foggy? Talk to me. Okay. So what else? Value and distribution. So risk is how we characterize uncertainty about the values that are variable. So it's one thing to say we've got some risk. It's another thing to say we've got some uncertainty. What can we do with risk?
Reduce risk.
Okay, how? I agree with you.
For example, picking stocks.
Okay.
One that has less risk, for example. Or making an option based on the value of that risk.
Okay, and so why does the stock have less risk? Since you brought it up, I didn't mean to pin you down, but what? What are some things that would go into that?
That's market and all that's a variable that is uncertain. So.
Okay, so there is some uncertainty with that, right? So, so risk is how we characterize the uncertainty about value. So what can you, I don't know if stocks is a good path to march down, but what can you do to minimize risk with stocks? Since you brought up, this is where I want to be careful whether I want. So if you want to, well, first of all, what is your risk? You buy Apple for $100 a share. What's your risk? Okay, not getting your money back, right? So how can you get rid of? Can you get rid of that risk? Not fully. How can you get rid of it partially? Okay. So that's one way to realize the outcome, but as soon as we do that, we're in a world of certainty once you sell it, right? So if you know that it's 100 and you pay your broker today, and now you're holding $100 cash. Now we're into a certain world. So what I'm interested in is the risk of holding it another period. So you're absolutely right. Outcome number one. I'll try to roll with this example. I'm not sure if how successful I will be. So we've got a $100 stock value, and we're hoping that it'll be 120 and not be down to 90. So one thing we can do is sell it, like you said, but that kind of just eliminates all of that risk without the upside of getting the 20. So we have a chance of losing 10 or a possibility of gaining 20, right? So this is a little bit of an advanced question, which is why I didn't know if I wanted to go this way, but how could we, is there anything out there that could give us a for sure outcome of 110? Is there any way that we could get rid of the risk of the 90 and kind of have this type of thing? Peyton, you got an idea? So if there's are there people out in the market with a taste for risk greater than you? Is this potentially a good deal? One thing I haven't done, I guess let's just say you've got a 50% chance of doing this and a 50% chance of doing this. So which one would you do? What is your expected outcome? This kind of ties into the stuff we were doing earlier. We can calculate this, right? So we got 50% of the 120 gives us an expected value of 60, and a 50% chance of getting a $90. So our expected value is 105. Right? Is there anybody out there that would be willing to pay $104 to you to take over your position? Would that be a good deal for somebody to buy your position in this at 104? Yeah, right? They're expecting to make 105, so to buy it today for 104 is a pretty good deal. So you could take $104 today. There's somebody out there that might be willing to buy that at 104, knowing that their $104 purchase now, remember if they buy it here it's either going to turn into 120 or it's going to turn into 90. But you can get rid of that risk by selling off some of that value today. If you're holding an asset that has these two outcomes, the real value of where I'm getting myself a little complicated here is that this would be like an option. So you own the stock, and you have an option to sell or options to buy in the future. So you can get rid of some of that risk that way. If this is the current expectations of what's going to happen with the stock, you can lock it in today through the options market. All right, so that was probably not so good an example. How else do you guys get rid of risk in your world? Let's just change to a different example. What do you do?
So let's say we do a risk our starting quarterback to get hurt, so we don't allow him to get tested practice.
Okay. All right. So you lower the chances, right? So you're probably altering the probability of getting hurt, right?
So you feel uncertainty in our risk. Is that what you're trying to get to?
Yeah, that's kind of what I want to get to of what we have with outcomes about the values versus the uncertainty of the difference between the two. Okay, so good. What else do you guys do in the real world here to get rid of some risk? If there's a chance of loss of something. I'll give you a hint. Think about your car.
I was thinking insurance driving or insurance.
Just insurance, yeah. So the insurance market, what's the insurance market all about? Well, there's a chance that you could crash your car and you're out a car. And if you're driving a $10,000 car and you're a student, then that's a lot of money to you. So how do you get rid of that risk? Well, there's an insurance company that's willing to take on that deal. Do you guys always get every penny back of your insurance policies? Of your premiums that you pay? Of course not, right? So, and that's when you hate insurance, because you cut a check for $100 a month every month. 100 times 12 is $1,200 a year. Yes, you've got a $12,000 or a $10,000 car, but it's going to take me 8 years to pay back if I go without an accident. So if I go 8-10 years, then I got screwed and the insurance company won. Is one way we tend to think about insurance, even though that's not exactly right, because there was a chance of you getting into that wreck that you hope didn't happen, but there's a small probability of you doing that. So the risk that you have can be traded, because the values is how we characterize uncertainty about the values of that variable. So we've got a car that's either going to be wrecked or not wrecked, right? And maybe there's medium wrecks in between, so I'm simplifying a little bit. But let's go to the totaling out a car. Let's just take those two. So we got wrecked or not wrecked. And we have enough data out there that insurance companies aren't really taking on a lot of uncertainty with that. In other words, they can estimate pretty well the likelihood of a 24-year-old male that's a student, that's a good student, whatever, good student discount, whatever, all the stuff that they do for insurance. They can estimate pretty well what the probability of a wreck is going to be. And so that means there's a market for risk. There ends up being a market for risk. Uncertainty is something that we can't get away from. There's no market for it, because there's always going to be some uncertainty in the distribution of those variables. We're not going to know for sure which one's going to come about or the shape of it. So if we think, if some of you had some statistics classes many moons ago, if you have a bell curve that looks like this, or you have a bell curve that looks like this, I should have drawn this maybe a little nicer. In each case, the top of the bell shows the most likely outcome. So that's the highest probability in each case. But how much variability depends on the distribution, on some other factors. And then there's other things that influence the shape of the probability distribution. So at the end of the day, the thing that we kind of hit on is the type of values of what those variables can take, and the chance that it's 60% or 65%, right? The shape of those things is going to matter. And so we overcome that in the insurance case, is they have lots of data that shows the expected outcome. All right, well, we'll work through some more examples there. Risk can be predicted, but not perfectly, as the financial crisis of 2008 showed. So risk can be predicted, priced, and traded. So you can get rid of some of your risk. There's not a market for your quarterback situation, right? You guys can't buy an insurance policy on that event such that you get a new quarterback in. So instead, you're taking steps to reduce that probability of injury through these rules that no hitting or whatever, right? So we're trying to alter the probability because there's not enough information out there to totally get rid of the risk, like what we do with insurance, potentially. Is we are absolutely, can be made in a risk-free situation of, if I have a wrecked car, the wrecked car is going to be made new, I'm going to be made whole. Or if I don't wreck my car, I'm still whole, right? So either way, through the insurance market, my outcome is a good car. But you had to pay for it. You had to pay for it according to the probabilities associated with an accident. And so you're able to get rid of that risk completely. All right, comments or questions there? This is always fun stuff when we start getting into some insurance. So we're going to continue on that note with the chapter 19. So let's take a break.